Imagine a storm so vast it engulfs an entire planet, darkening the skies for months and reshaping the landscape beneath it. Welcome to Mars, where colossal dust storms rage across the red planet, creating one of the most extreme weather events in our solar system. Mars, the fourth planet from the Sun, is often associated with its rusty red hue and barren landscapes. However, one of its most fascinating and fearsome phenomena is its global dust storms, which can engulf the entire planet for months at a time. These storms are not only a challenge for current and future exploration but also an integral part of Mars's climatic history. Understanding them requires an in-depth exploration of their causes, effects, and the role they play in shaping the Martian environment. The formation of global dust storms on Mars is a complex process driven by a combination of solar heating, atmospheric dynamics, and the planet's unique topography. Unlike Earth, Mars has a thin atmosphere composed mostly of carbon dioxide, which allows for rapid temperature fluctuations. As the Sun heats the Martian surface, pockets of warm air rise, generating powerful winds that lift fine dust particles from the surface. Over time, these localized storms can grow larger, merging into regional dust storms. Under the right conditions, they expand into global dust storms, covering nearly the entire planet. Scientists have observed that these massive storms are more likely to occur during Mars's southern hemisphere summer when the planet is closest to the Sun, and solar energy is at its peak. Once a dust storm reaches global proportions, it dramatically alters the Martian environment. The fine dust particles suspended in the atmosphere absorb and scatter sunlight, reducing surface temperatures while simultaneously warming the upper atmosphere. This creates a feedback loop that sustains the storm for weeks or even months. The thick haze can obscure the surface entirely, making it nearly impossible for orbiters and rovers to capture clear images or send data effectively. For instance, NASA's Opportunity rover, which had operated on Mars since 2004, ultimately lost communication in 2018 due to a particularly intense global dust storm that blocked sunlight and prevented its solar panels from charging. The long-term impact of these storms extends beyond exploration. They play a crucial role in redistributing dust across the planet, shaping dunes and altering surface features over time. Global dust storms on Mars also influence the planet's atmospheric evolution. Scientists believe that these storms contribute to the gradual loss of the Martian atmosphere, a process that has been occurring for billions of years. As dust storms lift particles high into the atmosphere, some of these particles interact with solar radiation, leading to the breakdown of atmospheric molecules. Hydrogen, a lightweight element crucial for water, escapes into space, further reducing the possibility of liquid water existing on the surface. This process has likely played a significant role in Mars's transition from a once warmer, wetter planet to the cold, arid world it is today. Understanding these mechanisms is essential for piecing together Mars's climatic history and assessing its potential for past or present life. The impact of global dust storms on future human exploration is a critical area of study. Any manned mission to Mars must account for the hazards posed by these storms, including reduced visibility, power loss, and potential damage to equipment. Relying on solar power during a dust storm could be problematic, as sunlight may be blocked for weeks at a time. Engineers are exploring alternative power sources, such as nuclear energy, to ensure a stable energy supply. Additionally, habitats and vehicles will need to be designed to withstand the abrasive nature of Martian dust, which is finer than talcum powder and may pose health risks if inhaled. Understanding the behavior and predictability of these storms is essential for planning safe and sustainable human exploration of Mars. Despite their challenges, global dust storms are a fascinating aspect of Mars's climate system. They provide a unique opportunity for scientists to study atmospheric dynamics on a planet vastly different from Earth. By observing these storms with orbiters, rovers, and future missions, researchers can refine their models and improve predictions about Martian weather patterns. Such knowledge is crucial not only for exploration but also for understanding planetary atmospheres in general, including those of exoplanets that may share similarities with Mars. As humanity prepares for its first steps on the Red Planet, the study of its global dust storms remains an essential piece of the puzzle, unlocking secrets about Mars's past, present, and future. Mars's global dust storms remain one of the greatest challenges and mysteries of the Red Planet. As we prepare for future exploration, understanding these massive tempests will be crucial for survival. Will we one day conquer Mars's turbulent atmosphere, or will these storms continue to shape the planet's destiny? Only time and science will tell.